Good morning, all of you. My screen is visible. Anyone?
Yes,
Yes,
sir.
sir.
Okay, fine. Okay. See that today we'll start the power electronics course. As you are aware that it's very important, and also if you understand this course, you can able to complete rest of the two courses also very easily. That means power semiconductor drives. Then some of the thing is from HVDC, then fax controllers, all this related, especially in the next semester I think power semiconductor drives. It is 90% of that subject is similar to this, only 10% machine related equations and all, rest of the things are same. The circuit, waveforms, explanation, everything is 100% similar. Only thing is here the load we connected as a some resistive load or inductive load or both R and L. But there instead of this load we may connect directly as a machine motor, like DC shunt motor or a series motor, or maybe induction motor or a synchronous machine. So like that, only the load is different, so that is the similarity. That's why try to understand this subject thoroughly, and that will be useful for the rest of the similar subjects. Now today's one or two classes we'll see only the introduction. We will not enter into the syllabus actually. My intention is to understand each and every one, what is the power electronics and what is inside we are going to study, what are the subtopics inside, and all full awareness you must get. For that I will take little bit more introduction orientation in the starting classes, then we'll start directly the course, so that it is easy for you, and what is the next topic all you must aware initially. So that is only the reason I will consider the introduction portion is a main priority. That itself you will get a lot of awareness. So that is the reason I am using 2 to 3 classes only for throughout the subject. Not only the first unit, up to fifth unit I will explain the introduction of each and every unit. Then only we'll start the actual course. So I am welcoming you all for this course, and there is a this is my name. And then power electronics will deal with 5 units. Briefly I will show the unit numbers. The first unit, power diodes and transistors. So this is the basic of power electronics switches. Normally here all the thing is related with switching action. Once if we start the actual controller, what it is there is the throughout course what we are doing is switch on some duration, switch off some duration, that's it. Any controller, it may have many number of controllers, but whatever may be the controller, what we'll do is only the, just a minute, yeah. So what we are doing is only switch on the device. The device may be anything. We may have a lot of devices. That may be diode. In general, diode is not come under power electronics. Only for somewhere we are using that diode and all. I mean some sub-component like that. But major components are here. SCR, silicon control rectifiers, BJTs, MOSFET, IGBTs, like that. Even latest devices also there, that will come under some other places. But at this course, we will use only SCRs, or a thyristor, BJT, MOSFET, IGBT. So these are the devices we will use. The characteristics of the device, all these things that will come under the first unit. Now the second unit, SCR or a thyristor, silicon controlled rectifier. This one is the heart of the course. Normally the device, or you can say that in the each controller we will use only the thyristors or a SCRs. Both are same, silicon controlled rectifiers or a thyristors. This is our switch. This is not ordinary switch. Wherever if I say switch, you consider it is a device, that too controllable device. Diode also we call it as a device, but it is an uncontrolled device. It is not in our control. Simply, if anode is positive with respect to cathode, the diode is going to be on. But whereas other devices, we must say at what instant device is going to fire. So that is all about our control. So that is the reason we can call it as a, this one is a control devices. So all power electronics. So before going to this, first one definition is required. Define power electronics. Anybody knows any definition? You can unmute and say if anybody aware this. What is the power electronics or define power electronics? Anybody? Any of you can answer if you know. So power electronics is nothing but a simply control and conversion of electric power. That is a simple statement you can remember, because throughout this course we are doing only the two things, not more than that. It may be different circuit, maybe control different control strategies, maybe different switches, anything you can use it. But outcome of this course is only control and conversion of electric power. What you are controlling and what you are conversion. So all that will come under all these durations of course. So control and conversion means normally we can see that any of the application, let it be, or any of the power, in general we have AC power. One of my sentence in that statement, conversion. Why the conversion is required? That is one point, question. Another one is a control. Why controller is required? So all applications, many of the application nowadays without power electronic, no such application. It may be home application or health application or military application, anything you can take it. That in any of the place, the component, there is a power electronics controllers are essential. In that I will come to that introduction portion after this units I am explaining here. Now this is the second unit. In that many of the topics are there. I will come to that syllabus portion after this slide. And third unit, you can see that. Yeah, tell me, ma.
Sir, some are waiting in the waiting lobby, sir.
There is no waiting, no. I am giving direct admission, because if you are login through college mail ID, you can directly can get it. But they
Sir,
are giving,
Kirtana.
yeah.
Yes,
But
Kirtana.
I think they used their personal mail ID. Just I am admitting, but next time ask them to join with the college mail ID.
Okay, sir. Thank you.
Yeah. So now this one, principle of phase control converters. This is the third unit. Very easy unit, little bit lengthy unit, because more topics need to cover here, but very simple. This is the one of the controller. So in the power electronics, majorly we have only 5 controllers. Among the total syllabus, we need to discuss 5 controllers. So controller means it is combination, control and conversion both, but in general word we call it as a controller. The name of this controller we call it as a phase controlled rectifier. This unit deals with phase controlled rectifier. So the function of this is it will convert AC to DC. Anyhow, the elaborate of this will come under next upcoming slides. This will give AC to DC. That means if you give fixed AC and it will give the variable DC. This is the beauty of this controller. But whereas here you can see that there is a diode. If I use diode instead of thyristor, here all from this onwards we maximum use only the thyristor in the device or a switch. So instead of thyristor, if I use the diode, that we call it as uncontrolled rectifier. This we call it as a phase controlled rectifier, because I used as a word is a control, because the output is going to control variable. Our control is nothing but a variable one, nothing more than that. So it is a variable DCs will be obtained. But whereas same circuit, instead of diode rectifier, if I use, instead of thyristors, if I use as a diodes, then also function is same here. Convert AC to DC only. But the difference of these two things is this DC is a fixed one. This one is a fixed one. So whereas here is a variable one. So that is the difference between diode rectifier and thyristor rectifier or SCR. So that is the major difference. You can see this one is a fixed one, this one is a variable one. The function is same, AC to DC only, whereas diode rectifier, if we give fixed AC, it will give fixed DC. But phase control rectifier, it will give variable DC. By giving fixed AC, variable DC, that is come under third unit. So like that, different supplies. Input may be single phase AC supply or three phase AC supply. Both need to cover in this unit. So that is half of the unit is come under single phase phase control rectifiers, and another half is a three phase control rectifier. So that is the two halves we are dividing that. Now fourth unit is come under this is also very important unit, but very simple and useful one. Now we can see here this combination consisting of three controllers. Here is a one controller I told, that is a phase control rectifier. It will convert AC to DC. This is a first one, phase control rectifier. Whereas here you can see that different controllers in this unit, three controllers are there. One is a DC to DC, that we call it as a chopper. The name here, if I call it as a DC to DC, also called as a chopper. This we call it as a chopper. And then what it will do, you may get doubt here, both is DC, then why we required this? The thing is, input is a fixed DC, but output is a variable DC. For that we required. If it is a fixed one, no need to use any of the controller, but I want variable. Why variable? Will come under that point later. So at moment, this unit deals with conversion of fixed DC to variable DC. That controller we call it as a chopper. So that is a second controller. And on that same, in the downside, you can see here there is another thing, AC to AC. So here that we call it as a AC voltage controller. Another name for this is here again dividing as a two controllers, AC to AC. This we call it as a AC voltage controller. Voltage controller. Another same AC to AC, another we call it as a cycloconverter. So these are the four controllers up to now. First, third unit phase control rectifier. Fourth unit deals with three controllers. One is a DC to DC. That means it will convert fixed DC to the variable DC. This function you must remember, all of you, throughout the subject. In general question they ask what is the function of phase control rectifier. what is the function of chopper, what is the function of AC voltage controller, then what is the function of cycloconverter or inverter, like that. So you must remember what it's going to do. So chopper is also called as a, or a DC to DC is nothing but a chopper. Second side must be as a controllable one. First one is a fixed one, DC is a fixed, another DC is a variable. By means of control strategy, you will get it as a variable DC. Then here AC to AC. What is meaning of here? Fixed AC to the variable AC with constant frequency. Once if we come to the AC side, there is a frequency also come into the picture. So we can say that AC to AC, there is a two controllers subdivision. One is AC voltage controller, another one is a cycloconverter. AC voltage controller function is, it will convert fixed AC to the variable AC with constant frequency. That is a function of AC voltage controller. Second one is cycloconverter. Again there is AC to AC only, but another change is there in that controller. It will convert fixed AC to the variable AC with variable frequency. So that is the key role in this power electronics when compared to the conventional control strategy. And this power electronics controllers for the especially speed control of AC drives or AC motors, because of this that become very popular power electronics. There is a normal case, variation of frequency is a complicated, but by using this, that means by using cycloconverter, frequency also possible to vary, that will given to the machine like a induction motor or a synchronous machine. If I change the frequency, speed is also going to be controlled. Like synchronous speed NS is 120 F by P, and that poles are fixed, and F is going to be proportional to the speed. Now I can able to control the frequency of that supply, then automatically machine speed is going to be controlled. That is the one of the easiest way to control the speed of induction motor. And other later anyhow some other techniques also will be there, V by F control, that is a voltage and frequency proportionately as to control, that will come under inverter and all. But that variations are possible in case of power electronics controllers. But in general, I want to change the supply frequency. For that is a lot more things we need to do. We have to use the alternator setup, and you have to change the excitation, and you'll get it, that and all very complicated. But whereas if I use directly as a small circuit cycloconverter, you can get it as a variable voltage as well as the variable frequency. That is the reason this will be popular for the AC drive applications. Now this is under fourth unit. So what it is? A chopper, AC voltage controller and cycloconverter. Chopper will give fixed DC to the variable DC. AC voltage controller will convert fixed AC to the variable AC with constant frequency. And cycloconverter is a fixed AC to the variable AC with variable frequency. So this is the cycloconverter. And last one is a fifth unit. So this is a inverter. So this is also very important for all other drive application. For AC drives and all, we will use only the inverter. Maximum cases we will use only the inverter. So that is the fifth unit. What is the function of a inverter? So this will be, input is a DC and output is a AC. This is the just reverse of the phase control rectifier. So in a phase control rectifier, in that is a third unit, it will convert AC to DC. Third unit will be AC to DC. You remember this way also, simple way. AC to DC is third unit. Fifth unit is a DC to AC, and then fourth unit is a DC to DC as well as the AC to AC. This is the both is there in the fourth unit. So these are the just titles of your units. First one is simple introduction of the switches. Here switches we are going to see, diode will read, then SCR. Anyhow, SCR will come here, all the characteristics and all, and then BJT, then MOSFET, then IGBT, insulated gate bipolar transistor. So a combination, nothing else. Here BJT and MOSFET, if you club, advantages of BJT, advantages of MOSFET, if you use, then you just make it to hybrid, then we'll get it as a IGBT. So that is the devices we are going to study in the first unit. Second unit, this SCR, complete SCR. So characteristics, that is a VI characteristics of SCR, and turn on methods of SCR, and turn off methods of SCR, and series parallel operation of SCR. Anyhow, I will show that syllabus also. So all related to the SCR or a thyristor, basic information we are going to study in these. This is completely switches other than the SCR, and here completely SCR. And from this onwards, after second unit onwards, completely controllers. So that is a all 5 controllers I told. Now fifth one is inverter. This is a fifth controller. So first one phase control, second one chopper, third one AC voltage controller, then fourth one cyclic converter, fifth one is a inverter. So these are the total units we are going to study in the next upcoming. Now some reference books and all, whatever you want to read, and now you can see that MD Singh, Power Electronics, Tata McGrail, another one is a PS Bimra, same Power Electronics, and then MH Rashid, that is also Power Electronics Circuits, Devices and Application. So these are the books, different Khanna publication is a Bimra, and Tata McGrail is a Power Electronics MD Singh. Another one is a Rashid, this also Tata McGrail, and these are the books. In addition to that, my textbook also there in the PHI publication. You can refer in the online any Google version if it is there. No need to buy that one. And these are the things are sufficient. But for the more problems, I covered in that book. PHI publication, Power Electronics is the title, and you just Google it, will get this book in the Google book, but it won't be download, I think so. So you just refer for the problems, because many number of problems I solved, even 20 problems, 30 problems also I solved, depends on the unit. So for that you can use my book in the PHI publication. And now we'll see the little bit elaborate in the syllabus. So there is a first unit, as I mentioned, other than SCR or a thyristor, will cover only the devices. That too I mentioned majorly 3 devices. One is a BJT, then MOSFET, then IGBT. So these are the 3 devices and comparison of all the 3 devices, so and applications. So these are the unit. So it is a very simple unit only. I think some of you are aware that in the basics of all these devices somewhere in the electronic subjects. So that is a, but the that one and this one is a different. What you may be studied BJT and all, or a diode and all, but that is not a power diodes, power BJT, power MOSFET. So there is a comparison or a slight different in the structure itself. That is while you are designing that or fabricating the device, there is a one additional layer will come into the picture. So that is the case only will use in the power high rating devices. Whatever we are using in the electronics, if I say diode, that diode is different and this diode is different. If I say normal diode is whatever you know, that PN junction and all, that is what in general diode. But here we call it as a power diode. It is not a normal ordinary diode. This is a power diode. One more layer is come into the picture. So that anyhow, that will the different for all the cases, not only the diode. For all the cases, you can make use of power. Here also see that power MOSFET, power BJT, power IGBT, like that. So that name itself little bit high rating, as well as the structure also going to be differ when compared to the normal case. So that I will explain while I am explaining this unit. So these are all about the characteristics of power diode, BJT, MOSFET, as well as static characteristics and switching characteristics also is there. Here you can see that switching characteristics. What is the switching characteristics means? Switching means what? There is a on and off. Once the device is off state, you are going to turn on the device. That means we are switched on. During that instant, from off state to on state, directly it won't be happen. In between there is a process is there. That process all about microseconds of time only. But what is going during that time, we will explain in this switching characteristics of all the devices like BJT, MOSFET, IGBT. So that means off state to on state. Similarly, once device is on, then what next? Off. I told in the initial sentence, throughout the subject, any controller, whatever I mentioned in the last slide, 5 controllers, whether it is a phase controller or a chopper or inverter or anything, what you can get, we are doing only switch on and switch off. That is fixed. Irrespective of function, what you are getting, AC to DC or DC to DC or DC to AC, anything, we are doing only one thing. We are switched on the device and switch off the device. So that is only our intention. For that, what happened, this characteristics we should know. What switch on the device means. On off, initially the device is off state, let it be, and we have to on the device. That we call it as a on process. Switch off to on. Once if it is on, after some time, after 4 microseconds or milliseconds or whatever the time you can give it for on, how much time it has to on and it has to off, that decided by our requirement or based on our application. Like a tap, just suppose I want more water, then what I have to do? So I can open the tap some more time, and I want only less, then you can less time it will be on and you can off some duration, like that. So same here also, you want more power or more output, then you to turn on the more time, and then less output, you turn on less time. That is quite simple. And the switching action on and off, again it must be off. See that initially off, then we turn on. How long? Let it be based on our requirement. I need 1 milliseconds of time. I turn on the device. Then what next? I turn off. What will happen? On is there, it is going to be off. How it is going to be off? There is a process. And while during off, then what are the things is going to be happen? So this we call it as all switching characteristics. Here, once completely on, that different. Completely off also different. But during on, during off, within a microseconds of time, there is some process is there. That process will discuss during off to on or on to off. That we call it as a switching characteristics of the devices. So that is comes under first unit. All the devices, BJT, diode, BJT, MOSFET, IGBT, and switching characteristics. Finally, comparison, because each device may have different advantages and disadvantages also. We cannot say that this device is completely ruled out or this device is better or something like that. So some particular instant this may be good, or some other this may be good, and then some here also drawbacks are there, here also drawbacks are there. But what we are doing is there is another device is here, combination. So whatever advantage of BJT and advantage of MOSFET we are using, and we make use that advantages to get as another device that we call it as an IGBT. So that later other some more devices also come into the picture. GTO, something like that. Many devices are there. So that further latest technology in the semiconductor devices. And now we'll come to the second unit. In the second unit, there is a different. Only the thing is SCR. Completely about the SCR we are going to study in the second unit. So the reason is it is a very important the device, very high rating device, and also very reliable and very useful one when compared to all other devices. SCR rating is more. You can able to use that device current rating and 3 kilo amperes of current also it can withstand. So that HVDC transmission and all high voltage DC transmission, they will use this type of devices, or many cases normally SCR is the preferable device when compared to the other device for the high rating applications. So that's why we introduced the complete SCR related thing for this unit. Now you can see that static characteristics, how the means what is the VI character. Static means VI characteristics, and then we can see that another topic is a two transistor analogy or two transistor model of a SCR. So direct device is there SCR, but there is a one provision or one option is available. If you have transistors, two transistor, you can make use of the two transistor like a PNP and NPN transistor. Use that two transistor and you connect such a way that the two transistor will work as a SCR. That is a silicon control rectifier. Instead of directly using one SCR device, if you have the two transistor, but now it is not required, or you can use two transistor to get it as SCR model, but directly SCR is available nowadays cheaper only, but there is option is available. I will explain that two transistor model or a two transistor analogy means by combining two SCRs such a way that two transistors you can get it as a what you call it as a SCR function. Now, after that, some protection of SCRs, any circuit or any controller or any equipment we need as a protection, even motor also. You can see that our machine lab, what is our protection in motor in our machine lab? Anybody? I think you may be complete machine 1 or maybe machine 2 also, anything, any machines we are using as a protection. What protection we are using for machines? Anybody? See, one thing is straight away there is a fuse, MCBs are under low test condition. I'm telling in the lab wise I'm saying. In low test case we are using as a water also there. We are pouring some water and pulley to cool that. So why cooling? Because we are operating under load condition. Once if you load it, there is a power dissipation is taking place. Why power dissipation? Losses, iron loss, then copper loss, all these things. This loss in converted in the form of heat. That heat will be generated in the armature. If you not cool down, you continuously run that machine with full load condition. The losses be converted into heat, and that heat will be generated more beyond the specified withstand limit of the armature. Then automatically there is a chance of getting the damage in the armature. So that is the reason we are using water there, and it will cool down. The temperature will be within the limit, like a transformer. Then what you are doing in the transformer? Not in the lab, because there we are using only 2 kVA transformer and all. It is a very less rating. But once if you go to normal transformer, distribution transformer or a power transformer and all, very high rating transformer we are using. Even megawatt transformers also we are using. Then there a lot of cooling mechanisms are there. We are using as oil there, transformer oil for cooling purpose, or for megawatt and all substations and generating stations and all. Lot more cooling mechanism, air blast, air cooled, both oil and air blast, like that many cooling mechanisms are used. So that is all about some sort of protection. Here also for a device like a CR also, once we are using the device in the circuit, we must and should use as a protection. So that protection, dI by dt protection, dV by dt protection, snubber circuit protection. So all protection also we need to discuss in this. Another one is a dynamic characteristics of a SCR. So what is dynamic characteristics and what is static? This is a VI characteristic. Dynamic characteristics also known as switching characteristics. Already I mentioned here for the above devices, BJT, MOSFET, IGBT and all switching character. Like that for SCR also there is a switching characteristics. During on, during off. Not on time and off time. That is once completely on is different and during on is different. So during on means off state to on, it will take some time. During that time what will happen? We need to observe that. That is a dynamic characteristic. Similarly, for other device like other device SCR also we need to see that dynamic characteristics, or another name is a switching characteristic, like what we mentioned in the above. That is a switching characteristics of a SCR. Then after that, series and parallel operation of a SCR. Anybody, why we required series operation and parallel operation? Anything. In case of machines also, come to the alternator. I think in machine 2 over or not yet. Suppose in the machine 2 and all alternators are there. Why that alternators are connected in parallel? What is the use of connecting two alternators are in parallel or two transformers are in parallel? I think it is there in the machines 1 transformers case. We have one experiment also in our machine lab, parallel operation of transformers. Like that, what is the require? Why we need to use any of our demand or power demand is more than one machine rating or one transformer rating, then we need to connect it in 2 or 3 or any number of transformers are connected in parallel. That is the requirement. So that means to meet our load demand, there is a current. So remember that we are connecting in parallel. So current will increase. So current demand or a load demand, load means current only, nothing. So that to meet the demand, which is not met by one device or one transformer, we need to connect it in parallel. Similarly, alternators. So the two or more alternators are connected in parallel. In substations also you can see that all alternators are running. If the demand is less, they will shut down one of the alternator. If demand is more, they may add one of the alternator in general case. So I mean you are synchronizing that alternators and all. It depends on our demand. We can able to use that parallel operation. Similarly, we'll come to that series operation. Like that in SCR also. As I mentioned, SCR ratings, high rating of SCRs are there. Suppose one SCR current rating is just for example, I'm telling 2 kilo amperes, one SCR. But our demand is 10 kilo ampere. What I have to do? One SCR cannot be meet the 10 kilo amperes of the demand. Then for that application, then what you have to do? You can use the 5 SCRs are in series parallel to meet our demand, current demand. So then we required as a parallel operation of SCR. Similarly, one SCR voltage rating is let it be as a 5 kV. Let assume that. But our demand 100 kV volts is there, our application. Then you need to use SCRs are in series. The combination of many number of SCRs are connected in series to boost that our voltage levels. So that for that reason we are using as a series operation. So this is also very important. They may ask the problems also. If current demand is this one or voltage demand is this much, our available SCR with you is something this much rating, then how many SCRs I need to connected in parallel or I need to connected in series. Based on that given data, we need to identify number of SCRs connected in series or in parallel. From this, what I am concluding is whenever you required voltage demand, you can go for as a series operation, and you required as a current demand, then you can use as a parallel operation. So this is the one of the topic. And then triggering circuit, or also called as a firing circuit. What is the meaning of triggering and firing circuit is here how the device is going to on, that's it. Or in the sense control, what we are doing, I want to operate the device with some firing angle, or also called as some degrees. So here control or conduction, at what instant device is going to be triggered, that circuit we call it as a triggering circuit. The instant at which the device is going to be fired, that we call it as a firing angle. I want to turn off the device. Suppose AC supply is something like this. This is our AC supply. I want to fire the device some this instant. This is maybe 30 degrees. Then at that instant the device is going to be fired. You have to design the firing circuit, and by changing that knob you can able to change the instant. Suppose somebody want to fire at 60 degrees, or somebody want to fire at 120 degrees here, this instant, like this. So the range is always 0 to 180 degrees. So where the device is going to be fired, that we call it as a firing angle. The instant at which the device is going to conduct or fire, so that we call it as a firing angle. So for that we need as different types of firing circuits are available. We will see that one by one. That is under this section, SCR or a thyristor triggering circuit. Another one is a commutation method. This deals with turn on. This deals with turn off. So as I mentioned, no, control, all these are the control devices. Control means what? When it has to be on, we are able to decide that at particular instant we want to fire, use that circuit, and we are firing the alpha is 30 degrees or 60 or whatever, that is on. Here in the case of SCR, one thing is a very important note. Once if it is on, let it be, there is a switch. Supply is here. Just for this AC supply, I am connecting as a one thyristor here. Thyristor, let it be like this. Then some load. This is a small circuit. So one thing is known to you. If it is a, what you call it as a diode, what is the operation? If anode is positive with respect to cathode, this will be closed. The switch will be closed. Let us assume that if it is a diode, then what will happen? Whenever anode is positive, let it be as a switch like this. This switch is a diode, let us assume that. Once anode is positive, this is anode, this is a cathode. If anode is positive with respect to cathode, the switch will be closed directly. Once switch is closed, your output is same as input. This is your output. It will give same as the input. Now, when it will be open. So here is uncontrolled. That's why anode is positive with respect to cathode. Automatically it will close without your permission. Simply supply is given to the circuit. Automatically it will close, and without your permission also automatically it will be off. Whenever this get is a negative, and what you call it as negative off cycle, it is a reverse bias, it will be open. That is about the diode. But now what I am meant to say is, now if it is instead of diode, if I use as a thyristor or a SCR, anode, cathode, gate, another terminal is there. This is anode, this one is a cathode, this one is a gate. Now that is the different here. In this is our control device. It cannot be fired without your permission. What is that? Even though if you give the supply, anode is positive with respect to cathode, now I call it as it is a forward bias only. But if that device will not conduct, what is the difference? Conduct means switch must be closed. Forward bias means it is ready to conduct. That is the difference. So forward bias is different, conduction is different. Whereas in case of diode, both are same. Once if it is forward bias, automatically it will conduct. But in case of thyristor, what will happen if I connect this device is here, if supply is given, anode is positive, this what will happen? The device will not close the switch instantaneously. It is ready to conduct, but it will not conduct. So when it will conduct, you have to decide. Who will decide? Means in our controller is a firing pulse. So what is that firing pulse here? Gate. So additional circuit is there. That additional circuit is a firing circuit. You have to say the signal at 30 degrees you must close the switch, or at 60 degrees you close the switch. Like that, from this circuit there is additional circuit is required to conduct the device. There is a two circuits here. One circuit is this, I call it as a power circuit, and to fire the device we need as a control circuit. So this are a triggering circuit. So from this circuit we are passing the signal to the gate. Yeah, at this instant of time you close the switch. At that point of time only our switch is going to close, you will get the output. So that means this all about your control in your hand. You have to pass the gate signal stating that you close the switch. That is the reason I call it as it is a control device. Whereas diode case automatically device is going to be controlled, but now you must give the signal to fire the device or to turn on the device. Once it's happened, now the device is on. Once the device is on, in the case of SCR, you don't have any control over the device. Only you have control once at what instant you want to fire. It is already fired. Then what? Next, but our logic is what? All the controllers, our intention is to turn on the device and turn off the device. But whereas here the problem is one problem. Once the device is on, you don't have any control over the device. But I want to turn off the device. Then only I need to get our variable voltage. So now I want to open this device. When I have to open, how to open? That is come under commutation circuits. So there is a two types of commutation circuits. That is a natural commutation, another one is a forced commutation. So commutation means the process of turn off the device. We call it as a commutation. So what is the process of turn off the device? How the device is going to be turned off. Once device is on, in turn we don't have any control. Like a diode, once the device is on, thyristor is on, how the diode is functioning, you will get the same. But why I call it as control, the instant at which device is conducting is in your control. That is the reason you can able to say it is a control device. But once it is control, it is not in your hand. So, but after some time I need to turn off. For that additional circuit is required again to open the device in the case of DC circuits. But whereas in case of AC circuit, the device automatically going to be turn off. It is not in your control, but it is going to be happen automatically. For that, one sentence you must remember, whether it is AC circuit or a DC circuit. So to turn off the device, you must current pass through the device must be 0. At moment you call it as a 0, but exactly or strictly speaking not 0, below holding current, that will come under characteristics time. At moment, in general, the holding current and 0 both are nearly same but not same. At moment you can just simplicity I am saying that current pass through the device is 0, automatically this device is going to be open. But whereas in case of this one, input is AC, every instant you can see that every pi, 2 pi, 3 pi and so on, every instant the current is automatically going to be 0, because it is a resistive load, voltage and current are in phase. So voltage is 0, current is 0, then every instant the device is going to be turned off automatically without any additional circuit, because input is AC. That is the reason that we call it as a natural commutation. So natural commutation means without using any additional circuit, device is going to be turned off that is we call it as a natural commutation. But whereas other like a choppers or inverters and all, what will happen? Input is a DC. If input is DC, I want to turn off the device like this, suppose circuit. Then what I have to do? I am using as a gate signal. I turn on the device. Once device is on, switch is closed. Device means switch only. I can call it as that SCR. If it is closed, your output is same as the input. Like here, in the input is AC if I give, but the device is going to be open at pi and 2 pi, 3 pi and so on. Every instant there is a natural 0 point is there. That's why automatically device is going to be open. But whereas here what will happen? In this DC case, what is the input supply? Here is DC. What is DC? Straight line. With any time interval you can take it. The magnitude is fixed one. Then what will happen? When the device will open? It never open normally because input is fixed one. Every time one switch is closed, so current is passing through the device. If current is passed through the device, device will not turn off. When the device will off, you need to bring that current to 0. Then only device is going to be open. How to bring it? Whereas here you are without using any additional circuit, current is reaches to the 0. That's why automatically it will open because current is bring to the 0 automatically or naturally, or line commutation. Natural commutation also called as a line commutation because line voltage or line current is going to be natural 0. That's why that we call it as a line commutation. Both are same. Line commutation are also called as a natural commutation. But whereas other commutation, that we call it as a load commutation, LC. What will happen here? So why load forced commutation, not load. Let it be, this is a forced commutation. The meaning of forced commutation is you make use of additional circuit or a commutating elements like L and C. Use that, you turn off the device. How to turn off? In turn, current pass through the device bring to the 0 by make use of a additional circuit or forcibly. That is the reason I mean to say that it is a forced commutation. Normally it won't happen. So use additional mechanism, that is a forced commutation circuit. Using that commutation circuit, forcibly bring that current to 0. Then once it reaches to 0, automatically the switch is going to be open. Again give the pulse, switch will be closed. Use the forced commutation, open it. Then again firing circuit, close it. Like that. Our intention is to turn on the device as well as the turn off the device. So like that, you keep on do that process, your average output voltage is going to be changed. Then whether you want higher voltage or you want lower voltage, that decided by what? What we can decide that how long you turn on the device. That's it. So if you turn on more time, you will get what will happen? More output, and you turn off less time, again turn on more time, you take average of that. So on time is more, you will get more output, off time is less, then you just take it as average of that. Off time means what is the output? Anybody? Any circuit here, if I say something off means open, the switch is open. What is your output? And here also switch is open. What is your output? One switch is open, switch is on, everybody knows output is equal to the input because closed, no, here is closed. If this is closed, output is same as the input. If this is open, or here also anything, if closed means input is equal to output. If it is open, what is output? Anybody? Now it is open here and here also open. What is output you are expecting? Don't know. What is there? It is open, output is 0. No connection between input and output. So output is simply they are getting 0. So if you connect this, output will be same as the input. If you disconnect this, means open the switch, your output is 0. Here also same. If you close the switch, your output is same as the input. If you open the switch, output is a 0. So like that, you can get it as a, now what will happen? Sometimes you are getting some amount, sometimes it's 0. You take average of that, you will get it as a some new value. So that we call it as a your average output voltage. Suppose output is a 10 volts, let us assume that. Input is a let it be 0. Then if you take average, what will happen? Based on this same duration, if you take let it be 5, just for example I am saying, and now you increase this, then what will happen? By 2, then 10. If you increase, then by 2, let it be like that. So now if based on your on duration, you will get more output. And now suppose off duration is more, on duration is less, you will get less output. If you take average, you will get less. Like that, just a simple example. So by controlling your on period and off period, you can able to get it as a variable output voltages. So this is the second unit. So here all the things now only deals with this, not this. This is under third unit. So input is DC means third unit, I told no. So for the previous slide, I mentioned SCR. So these are all the commutation circuits. Now we can see that commutation circuit means off. How it is going to be off? So that circuits we are deals with whether it is a natural commutation or a forced commutation. Both commutating circuit we are able to see this in this unit. That is about what you call it as second unit. So it will deals with only SCR characteristics, static, dynamic, series operation, parallel operation, on process, off process, all things is under second unit. Now third unit onwards our controller is going to start. So each controller you know that functions and all 5 controllers. So third unit will come under first controller, that is a phase control rectifier. I am recapitulating that whatever controllers discussed in the previous slide. First one is phase controller. Function of phase controller is it will convert fixed AC to the fixed variable DC. That is a phase control rectifier. And which type of commutation will used in this controller? It is a natural commutation. The reason is blindly remember one thing, two types of commutation. One is a natural, another one is a forced commutation. All the controllers which is input is a AC, that we call it as a natural commutation except step up cycle converter. I will explain at that moment. Even though input is a AC for the step up cycle converter, what is meaning of step up and step down? Cycle converter function is it will convert fixed AC to variable AC with variable frequency. Now if I want to decrease the frequency, I need step down cycle converter. If I increase the frequency, I can use step up cycle converter. So for that, one common statement for the what are the controllers is related to which commutation. For that, phase controller is AC input. That's why it is a natural commutation. AC voltage controller is input is AC. That's why it is a natural commutation. Cycle converter input is AC. That is the reason it is a natural commutation. But the cycle converter is two divisions. Step up cycle converter, step down cycle converter. Step up cycle converter, even though input is AC, we require as a forced commutation. That I will explain the circuit and all at that unit. But step down cycle converter, natural commutation only. And another statement is a forced commutation. So what is the forced commutation? If current passing through the device is not 0, the device will not turn off. That's why current pass through the device make it to 0. For that reason, you required as additional circuit or forced circuit is required to turn off the device. So for that, choppers. So chopper is function is, if you know the functions of all, then you can decide which commutation for what type of controller. So chopper is a DC to DC. That is the reason you can use as a forced commutation, because it never go to natural 0. And what is the inverter? Inverter will give input is a DC, that's why we can use a forced commutation. And other than this two, phase control rectifier, Then AC voltage controller and cyclic converter except step up, all the things are natural commutation. So these are the different types of commutation circuit we need to use in the different controllers. So for the phase control rectifier, we can able to use as a natural commutation. Then AC voltage controller also natural commutation. Then cyclo converter except step up, that you remember. So these, for this group of controllers, will use natural commutation, means automatically it will happen, and this will not be automatic. You have to use additional circuit commutating elements like L and C. We have to use forcibly bring the current pass through the device to the zero. Some current is there and you have to bring it to that current to the zero level. So opposite force you have to make it to get it as a zero. So these are about first 2 units introduction. And anyhow, again I will come to that other controllers also for the next class, and you see that where the total subject and syllabus introduction is very important. That's why I will take little bit more time, even 3 hours of time I will allocate it for that introduction of all the units. Then we'll start the unit wise. So that much simple, but you must understand the thing. If you have any doubt, you can ask me at any point of time. That much easy. Once if you understand the thing, then the rest of the things are very easy. Nothing is there derivation or small derivations also there. What is the average output voltage? What is the average current? And what is the efficiency of the controller? And what is the what you call it as form factor, ripple factor, and the output, all small derivations, that small thing. That too, one derivation if you know, the rest of the things are small changes only. Integration limits will change, the all other things are same. And we'll see in the next class. If you have any doubt, you can ask me. And the next class I will start just continuation of this, and we'll go ahead. And attendance is 51. I will take attendance directly. I will download this sheet. I will show you if you want to see the attendance. I will share that also, because here in the attendance part, that will give time. At what time you joined and when you leave and how many times you joined and left, all these things is going to be displayed here. I will share you one so that it will aware. Even if you left in between, everything it is going to be see. It is sharing now screen. See, myself I joined at 11:27, and see others also. If anybody left, joined, left, all the things. See, somebody left already. Arishana, and then this left, Kirtana, but again joined. So like that, all the data is available here. You don't go in middle. If your presence is less than 50 minutes of time, I will treat it as absent, because 1 hour class. Maybe initially 5 or 10 minutes maybe late or something. Based on this, automatically attendance sheet is generated. So this will go there and it will give the attendance. So that's why you take care of these names and all. You don't change that all the way. Whatever names you join, you use that. Here you see that Kirtana used as a guest. You try to use your mail ID, normal college mail ID, that name will come here. Based on that name, attendance. If the name is slight change also, it won't come. So that's why I will post attendance every day. You just check it. If any discrimination is there, just inform me. I will check it and I will update immediately. And if you have any doubt, you ask me. Otherwise, you can leave.